Hi guys, in this tutorial I will show you how you can write an evaluation or interpreter for let's say JSON-like code. So what we want to do is we want to be able to do things like this. It should be 11 or things like this. Which should be 20, I guess. Okay. So what we do is we define our evaluation function. Well, and we call this, let's say, code. And to get this, we need to list all the keys, which we can do with, I think it's the keys method. If I'm not mistaken, yes, I know there's a syntax error. Yes. So now we define the add function. So if we don't get to our two arguments, then obviously that's the wrong number of arguments. So argument 1 is this, and this. And then we have to also evaluate these, of course. Now we need to make sure that if we get an integer, that we don't go into this part, because so I think it is okay. So if this is an integer, then we don't need to evaluate anything, because an integer evaluates to itself, of course. So now say this. Okay. 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 So let's convert this to a list first. And now That's of course the wrong kind of parentheses, should be brackets. Okay, so here we go. So this is the arguments. So this is the function, the name of the function. And the arguments are these. Be like this. Yes, of course, this. Okay. And now we can, of course, also refactor this a bit. So function name functions. Functions. Function and if it's not in there, we just raise an exception. Function does not exist. Go. And then delete. We need a dictionary. Yes, and I pass this here. And then also need to pass it to this. Right here as well. And now we also need to return the value, of course. And now we're back at our end. Okay, so now we can also, of course also, let's say you can do this actually if you want. Let's copy this and say subtraction and subtract, of course. Okay, then let's say this should be a subtraction of 3, 2. And now we have 6, because this is basically 5 plus 5 plus 3 minus 2. Alright, so, okay. Now, let's refactor this again. We can create a class context, which has functions. And instead of passing functions, we pass our context. Go. Let's see if we made a mistake. Okay, so we made a mistake. did you make a mistake? Line 51. Yeah, so we need to pass the context, of course, instead. Okay, so we're back where we were. So now we can refactor this a bit. I can say now we can do this. Then instead of this, we just do context count function name arguments return the value, and here also return the value, and now we should get 6 again. Okay, so now we also want to have the ability to define our own functions. So let's say we have something like let's call this function square. Define square. Mistake somewhere. Okay, so square, and this takes an argument we call value. And what we do is we say we want to multiply value by value. I hope I did this correctly. Okay. Yeah, but let's prefix this with the dollar sign. Okay, so now we can create a function which takes 3 arguments: the name of the function, the arguments, and the actual code for the function. This, and the name is this one. Arguments are this, and code is this. So okay, and now we will just create a function. So we also create the class function, which takes the arguments code. No, we don't need this, I think. Or maybe we do. Let's see. So our function is this. Oh, let's also pass the name, I guess. This name arguments code, and then like this. So if we evaluate this, okay, we made a mistake. Line 10 is here. Right. Okay. So okay, because this doesn't return anything, of course. So as we can see now, we have this. And let's add some boilerplate code. We should call okay. So now we can see we have our part of the code that defines the function square, and we have part of the code that one would like to call this function square. So now we need to implement this function call. So which means we need a reference to the eval function. Which is this one. This yeah, let's rename this so people don't confuse it with the default Python eval function. Which is great. Or actually, just let's move this into our context class. This might be easier and better style, I guess. Then we can also get rid of this because now it's then we have to use cell. Then we can do this. Okay, let's see if everything is correct. No, so missing one. Line 77, which is here. But then we actually don't need this. Where are we? Come on. Still 977. Yeah, we don't need this anymore either. Those must be it. Okay. So then we need to rewrite this, of course. Using context our email. Okay, great. So now the number of arguments must be the same. So if the length of arguments we get here is not the same as the length of arguments this function expects, then we have the wrong number of arguments. Plain and simple. So if we do like this, we should see our exception. Perfect. Okay. Otherwise, for arguments, for functions have a scope usually in most programming languages, and the scope is a stack. So let's define a new scope, which is a dictionary. And what we do is we do this. So new scope is essentially this. The name of the argument is this. Sound. Like this. Then we need to push this. And then we need to for statement then at the end we need to remove the new scope again. This. So with this we evaluate all statements. and save the return value. So this yet should not work. Even if we supply the correct number of arguments, this should still not work, mostly because this is not defined yet. So let's define this. Let's create the multiplication function like such. Okay. So now we need a way to access variables, and we use a $sign prefix to indicate that we are trying to access this value. So if this is a string, and this is a $sign, then we access this variable. Okay, so current scope is simply the element on top of the scope stack. So if name in current scope name, of course we need to remove the $sign. So else this variable does not exist, right? Okay, so let's see if this works. And it works, 25, which is the square of 5. Let's remove this. Okay. Let's also add a print function. Let's do this. So now we simply remove this and do this instead. And voila. So now we can also do this instead. And voila, now we have an interpreter that can create functions and use functions. And we of course, this is very basic yet, so we should add some more things. For example, we want to do, let's say we want to have a loop. So so let's implement a while loop. So a while loop of course needs a condition, which is going to be this, this, and it has a body, which is a list. So we evaluate this condition. And if not, then we break. So like this. And now we do this. Okay. And of course, a while loop doesn't return anything. So now we need to add it to our dictionary. And let's also, of course, add a comparison function. Okay. Here we go. And now we also need a way to change the value of a variable or define a variable to begin with. So we're going to call this set, which of course takes 2 arguments. Namely the name of the variable and the value. And we don't evaluate this because this should be a constant string, but this we need to evaluate. Okay, and then we need to get access to the current scope. And just set this and return. Okay. Okay, this is also turning this. Okay, so let's see if this actually works. So we say set number to 5, and then let's print our number. Syntax, that's okay. So this should be an exclamation mark, of course. And there should be a comma, of course. So now we don't have a scope yet. So we need to add a default scope. Okay, so we see we can set the number and we can print the number. And we can also add some predefined values. For example, we could do this. say pi is equal to 9. And now we could also do this. And voila. Okay. There's one slight issue if we have a hierarchical scope, but we will address that later. So now I want to be able to say while the condition is well, number is smaller than, let's say, 10. I want to do let's indent this a little bit so you can see what's actually going on. This. Okay, so I want to print it. Then I want to add 1 to the number. So set number to plus 1 number. And hopefully let's initialize number to 0. And hopefully, if we get everything right first try, then we should. Okay, variable does not exist, number. Okay, so yes, because this needs to be different. Does it actually generate? Let's see. Okay, so and now we have our while loop. And now we can actually do, so we can do things like this. Let's say we want to square the number instead of just incrementing it. Like this. Oh, and of course, the square of 0 is 0. How do I terminate this? Oh, yeah, okay. That was unexpected. Yeah, so the square of 0 is obviously 0, and the square of 1 is obviously 1, so we have to set this to at least 2 for it to work. And now the next square would be 265, so let's just increment this a bit. Okay. So now we always square the number until we are bigger than this number. We can also do something like this. 2. And here we could start at 1 actually, because 1 times 2 is 2. And now we get this neat little thing. And let's also create an if. So instead of just a while, I also want to type if, which also takes two arguments. This, so it also has a condition, and it also has a body, and if this is true, and also just. So now let's say we want to save this as well, and add our if function. So is odd, it's one argument. Okay, so now let's go back to incrementing it, but now I only want to print it if it's odd. So if condition is odd, number, then we print it, and this should actually kind of done it. What's the problem? Here, oh, here it's missing here, here. So, okay, now I forgot a comma again. All right. Where's the mistake? Okay, we have 9. All right, so this needs to be a list. Okay. How do you stop a program in idle shell? This is insane. No. So and now it should only print the odd numbers. Okay, and there you have it. This is how you write a very simple interpreter. Of course, usually you'd need to parse some form of code, like let's say you want to have something like this, different square value. So of course, you'd need to have a parser that translates source code into this, let's say, JSON notation before you can actually interpret it. So this tutorial will also address, will only address this part and not this. But maybe I will create a tutorial on how to write a parser for this later. But for now, this just focuses on the actual interpretation part.